Hi, my name is Hao Xi, and here I'm giving an overview of our group project of STAT 159. Our project reproduces Ranson's analysis on the impact of weather on criminal activities in the United States. His analysis involves weather and crime data of 1980 to 2009. And in our project, we use the data of Alameda County and analyze the relationship between crime and weather of the entire county and of different regions within the county. We first extract crime and weather data and bin the weather data and aggregate it by month with categories Ranson uses in his paper. Then to test whether East and West Alameda has the same weather, we perform a stratified permutation test. And then we fit the Poisson regression model on the East and West crime and weather data, and on the data of the whole Alameda County. Our results shows that within one county, the weather is significantly different in East and West Alameda, and the relationship between crime and weather is also different for the two parts. Therefore, Ranson's assumption that each county has one united crime and weather relationship is not reasonable. Here, as you can see, is our GitHub repository. In the notebook, in the README.markdown file, we have the names and email addresses of each group member, and we also include the source of data we use in our project. We also include some important reproducible steps that's needed for reproducing our project. And in a notebook directory, we have all the cleaning scripts as well as scripts for regression modeling and hypothesis testing. Some functions we wrote are included in the code directory right here. And we also include unit tests for these functions. And in the analysis PDF, we showed our analysis and the conclusion in details.
My name is Winnie, and now I'm going to be cover the clean data part. In our project, we have the weather data and the crime data. And for the weather data part, to calculate the weighted average temperature for each county, we create a set of grid points across the Alameda County by first generate the rectangle set of grids and then fill it out with grid points in Alameda County. And you can see there is our grid points. Each point are 5 miles away from each other. And for the generating weather station weights, we calculate the weights for each station by average inverse distance from the station to every grid point in Alameda County. And there are examples for the 4 station and the 4 grid points. The weather data we use the original from the Global Historical Climate Network, and the data we use are only contain the 27 weather stations that have the sun data reported during the 1980 to 2009 time period in Alameda County, and they are the snip of our data. We only focus on the maximum temperature and the precipitation. And move to the crime data part. We get the pre-clean crime data from this website, and you can see the original crime data contain over 100 columns, but we're only interested in the actual oil fields, which is the total number of crime per month in Alameda County.
Michelle, yeah, I'm going to give more detail about the cleaning process of weather data. Since there's multiple stations for one county, but we only want one weather data per county, we are using a weighted average of the weather station's data. As the Ranson's paper showed this example, if we only take the simple weighted average, there will be some inconsistency for the time period around this area. So we are using a bias corrected term. The algorithm that Ranson works as following. First, he initialized all the intercept term for all weather station as 0, and then at each iteration, to update the intercept term, he randomly chose a weather station as the reference station. Then he used the intercept term from the previous iteration, and then plus the average temperature difference between the weather station and the reference station. So after few iteration, the intercept term will finally converge to some criteria. In our example, in our project, we choose the intercept to convert within 0.02. And we also add a parameter in the function that generate this bias correction, so you can have control about the converge rate. The detail of the implementation of this algorithm is given in this generating corrected weighted weather notebook. After having this bias corrected weather data, we now bin it according to Ranson's criteria to 11 bin for maximum temperature and 5 bin for precipitation.
My name is Dong Seong. As the first analysis seeking for the validity of the Ranson's approach, we have focused on weather in Alameda County. For our analysis to be valid, we have tried to follow the method Ranson had used as much as possible. As one example, we have matched the time range covered by Ranson. After the above process to match with the Ranson's approach, we have conducted the stratified permutation test. Then, from the set of resulting stratum-wise p-values, we have derived the combined p-value by the Fisher's combining function. The details of this permutation test and applying Fisher's combining function can be found in this notebook, Test Berkeley, Livermore, Same Weather. In our hypothesis test, the null hypothesis is Berkeley and Livermore have the same weather, and the alternative hypothesis is the weather in Berkeley and Livermore are not the same. With our derived combined p-value, which is 0, we can deduce that our case falls under any of the simpler nulls is false case. Therefore, we reject the null hypothesis. Our argument, casting doubt on the Ranson's approach, is basically focusing on the following question. Using the data from only 2 stations for the Alameda County is enough? We know from the result of our hypothesis test, the Alameda County's weather is not identical across its area, and the 2 stations used in the Ranson for the Alameda County are located in very different cardinal points. Berkeley is northwest and Livermore southwest. Therefore, hoping to capture the weather characteristic for the Alameda County by using only 2 stations seems questionable. If he had included a station located in northeast or southwest of the Alameda County, the output after his bias and weighted average correction would be different. In short, using data only Berkeley and Livermore stations seems not enough to generate precise analysis. Next, we have checked whether the lack of weather data problem becomes worse through one of his cleaning processes. He had dropped on year-level county data if that year contains at least 1 month of missing weather data. This above process shows us that there is no intersected not reporting day between the Berkeley and Livermore stations. In other words, there exists weather data for every day during the time period for the Alameda County. Therefore, after the Ranson's bias and weighted average correction method, the Alameda County does not fall under the at least 1 month of missing weather data criterion. Hence, dropping on year-level county data based on missing weather data alone is not a concern. However, we can observe one big problem. There is everyday weather data for the Alameda County, but there are 1,644 days or 4.5 years of the weather data which solely depends on either one of stations for the Alameda County. Then, even though we have obtained the corrected version, of weather data without any missing day for the Alameda County through his method, the resulting corrected weather data is questionable. It means if we consider the 4.5 years, our lack of weather data problem due to using only 2 stations seems to become worse. In conclusion, even though Ranson's approach in dealing with problems seems reasonable in some cases, the doubts related to the deficient data do not seem to fade away.
Hi, I'm Chan. As last part of our group project, which is related to assignment 6, we'll analyze whether the east and west parts of Alameda have different relationship between crime and weather. So null hypothesis is that 2 pieces of Alameda have same relationship, and alternative hypothesis is that 2 pieces of Alameda have different relationship. At first, to compare 2 hypotheses, we treat Alameda as states and 2 parts of Alameda as county. So null hypothesis become whole Alameda state is itself only one county, and alternative hypothesis become east and west are 2 individual county of Alameda states. Now we fit the Poisson regression twice for 2 hypotheses using Ranson's second equation. In Ranson's equation, there is states by month effect and county by year effect. However, first model, which treats whole Alameda state as one county, excludes the states by month effect since whole Alameda is itself state. This is a summary of our first fitted model, and this is a summary of our second fitted model. Generally, to compare models, we usually use a root mean squared error called RMS error. However, the second model has always less RMS error than first model since it has more variables than first model. We can see that first model's RMS error is almost 1,100, and the second model's RMS error is 485. Therefore, we need another test to compare 2 models. We'll use permutation test. If 2 parts of Alameda have same relationship, crimes in east and west would occur randomly. The 2 models' RMS error would be not much different. However, if 2 parts of Alameda are different, the RMS error of the second model would be much lower than first one. So we permute the number of crime in west and east each month. For example, east crime data of 1980 February only get 434 or 8,528. After permutation, we fit again 2 models and get a difference of 2 RMS error. But even if we permute the data, the whole crime data would not be changed. So the first model's RMS error would not be changed. Therefore, we only need to calculate the second model's RMS error, which treats east and west as 2 individual counties. If alternative hypothesis is true, our original RMS error would be much less than other permuted RMS errors. Now, after we permute 1,000 times, our original RMS error has p-value less than 0.05. So we can reject the null hypothesis and conclude that east and west Alameda have a different relationship between crime and weather.